Okay class, you're welcome once again to another exciting video lesson on my YouTube channel, Maestro Science Guide. Now if you're just seeing this YouTube channel for the first time, please do well to like, subscribe to this channel. Alright, now in today's video lesson, we're going to be talking about a very important calculation aspect in chemistry, which is known as the solubility calculations. Now, what then is solubility? We can define solubility as the amount of substance that is dissolved in 1 dm cube of the solvent or water. Now, water is universal solvent. Okay, so that is solubility. Now, without wasting time, we need to I need to show you guys how we can, solve, all right, calculate questions involving solubility. Now, first and foremost, I want you to know that the standard unit for solubility in most cases is mole per dm cube. However, solubility can also be in gram per dm cube. All right, solubility can also be in what? Gram per dm cube. Now, to calculate your solubility in mole per dm cube, we have this formula. Solubility is equal to mass times 1000 over molar mass times volume. Now the volume is in centimeter cube. All right, so when we have volume in centimeter cube, that is why we need this 1000 here. So it's mass all over molar mass, mass times 1000 all over molar mass times volume. All right, or you can even do it this way: mass all over molar mass times 1000 over volume, whichever direction. So this will help us get our solubility in mole per dm cube. However, if we want to get our solubility in grams per dm cube, how do we get solubility in grams per dm cube? Very simple. We have mass times 1000 all over. Now, solubility in grams per dm cube, we don't use the molecular mass. The molecular mass is actually removed from the formula. So we just have over volume in centimeter cube. So this will give us solubility in grams per dm cube. All right, grams per dm cube. So this is what it's going to give us. All right, so with this formula, all right, we can go into questions. But before we go into questions, it is very essential for you to note this. Please note that the mass of water, okay, the mass of water is same as the volume of water. So take for example, you see a question and it tell you calculate the solubility of a let's say 5.0 gram of sodium chloride in 20 grams of water. You see something like that. So they didn't use volume, but they just said 20 gram. Now please know that 20 gram is also taken as the volume. So the 20 gram, all right, is also taken as the volume in centimeter cube. All right, now how is this very true? It is very, very true. Why? Because of density. Now we know that density is equal to mass over volume. Now the density of water is 1 gram per cm cube. All right, 1. Density of water is 1 and it is in cm cube. So if we say 1, density of water is 1, equal to, let's say the mass is 20 and we want to find our volume V. So by the time we cross multiply, what we are going to have, we're going to have 1V is equal to what? 20. Then divide both sides by 1. 1 cancel out 1. Therefore, V is equal to 20 divided by 1 is still 20. So we now have 20 centimeter cube. So that is why I said the mass of water is same as the volume of water. All right. So let me even modify this in centimeter cube. So the mass of water is same as the volume of water in centimeter cube. So you will now have to convert. When you now want to convert, all right, from centimeter cube to dm cube, all right, when you now want to convert, from centimeter cube to dm cube, you will now divide by what? 1000. Okay, now divide this by 1000 to now get your volume in dm cube. Or better still, you can now impute it into any of these formulas and just substitute. Now let's go into the areas of questions. Let's break down this question 1. Question 1 says calculate the solubility in mole per dm cube of 10.2 grams. So we're given our mass. Our mass is what? 10.2 gram. All right. Then now we need to get the molecular mass of this. So to get the molecular mass, is equal to, we just add up. All right. So lead Pb is 207. So 207 plus this 2 is affecting oxygen and nitrogen here. So it becomes 2 times 14 because nitrogen is 14. Then here becomes oxygen is 16. 16 times 3 is 48. So times 2, the outside one. So plus 48. Or let me just do it this way. 3 times 16 times, okay, let me put these 2 outside. So we have 2 open bracket 3 times 16. It's better like this. So if we do this, what we are going to have, so when you just do this, what we are going to have is here will be 27 plus 28 plus 3 times 16 is 48. Then 48 times 2, that's 96. So by the time we add up, we have 96 plus 28 plus 207. That will give us 331. So the molecular mass, all right, the molecular mass of this compound is 331. Now we're given our volume. Our volume is what? 15.6 gram of water, right? Remember I told you the mass of water is same as the volume of water in centimeter cube. So this can also be, we can also say, or this is still the same thing as saying 15.6 centimeter cube, all right, of water. So now bringing it into our formula, so we can use any of the formula, all right. So we can use solubility is equal to mass times 1000 over.
So using this formula, let us impute all these our parameters into this formula and then get our answer. So we have solubility equal to, what's our mass? Our mass is 10.2 times 1000 all over our molecular mass 331 times, what's our volume? 15.6. So when we just put all of these into our calculator, we're going to get, when we do all of this, right, we're going to get 1.97 mole per dm cube. If you put all of this, you times this, multiply this, and then use this to divide this. This is what you're going to get, 1.97 mole per dm cube, approximately 2. All right, now let's move to the second question. We have question 2 on the board. Let us break down question 2. Question 2 says, if the solubility of KHCO3 is 0.40 mole per dm cube at room temperature, calculate the mass. All right, we're told to what? Calculate the mass. All right, now in order to calculate the mass, so we are still going to use our solubility because look at it, mole per dm cube. So that means solubility is equal to mass times 1000 all over molar mass times volume. So what's our solubility? 0.4 is equal to, what's our mass? That's what we are looking for. They say calculate the mass. We'll call it Y times 1000 all over molar mass. Now let's solve for the molar mass of KHCO3. Molar mass of KHCO3, we have 39, K potassium 39 plus hydrogen 1 plus carbon 12 plus oxygen is 16. So that 3, this 3 here is affecting oxygen 16. So it becomes 16 times 3. Okay, so the atomic masses. So when we add up, this is 40, this is 48. That will give us 88 That's everything. This was 100. All right, 100. So our molecular mass is what? 100 times, what's our volume? Volume is 100 centimeter cube, so put 100. Now, the reason why we are always putting over 1000 in this formula, please don't forget, the reason why we are always putting over 1000 in this formula is because of volume in centimeter cube. So when you have volume in centimeter cube, you put this 1000 here. If volume is given in dm cube, if volume is given in dm cube, please do not put this 1000 again. All right, so 0 cancel out 0, 0 cancel out 0. So altogether we then have 0.4 is equal to 10y all over what? 100. So by the time we cross multiply and divide, what we are going to have, it will be y is equal to 0.4 times 100 divided by what? 10. Alright, so this cancel out this, therefore our final answer becomes, therefore y, which is the mass, is equal to what? 4 gram. That becomes our mass, 4 gram. So this is it for question 2. Class, now let's look at question 3. All right, question 3 on the board. If 250 centimeter cube of a saturated solution of KNO3 at 30 degrees Celsius produce 3.40 gram of the dry salt, calculate the solubility. So when they tell calculate the solubility, in most cases you are expected to calculate for solubility in mole per dm cube. All right, so let's go into that. So we have our normal solubility. By now it's supposed to be used to the formula. All right, so our solubility is equal to 3.4 times 1000 all over molecular mass of KNO3. So we have 39 plus N, which is 14, plus 3 times 16, that's for oxygen, so that's 48. So by the time we add up, what are we going to get? Okay, let's do it. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have 1, carry 2. All right. So 5, 6, 7, 8, 9, 10. So we have that's 101. All right. 101. So 101 times, what's our volume? 250 centimeter cube. You see, using centimeter cube, because that is 1000 is here. So when you times and you do this, what you are going to get is 0.134 mole per dm cube. So when you times this and you times this and then you divide, all right, you're going to get this 0.134 mole per dm cube. Now, what if they ask us to calculate solubility in gram per dm cube? For solubility in gram per dm cube, we're going to have the solubility is equal to the mass 3.4 in gram per dm cube. Now, gram per dm cube. That's what I want to do. 3.4, all right, times 1000 all over. Now, we are not going to use our molecular mass. For gram per dm cube, we are not working with what? Molecular mass. So we just say all over what? 250. All right, so when you times this, all right, and divide by this, you are going to get 13.6 grams per dm cube. So this is how to calculate, all right, in gram per dm cube. So in mole per dm cube, this is our answer. In gram per dm cube, this is our answer. Now, how do you simply convert from gram per dm cube to get your answer in mole per dm cube? Just simply divide by the molar mass. So when you just divide your answer here by your molar mass, what are you going to get? You are simply going to get your solubility in moles per dm cube. Okay, class, let's solve this final question on solubility calculations. All right, so this question will be the final questions that we're going to be looking at for this video. All right, so all the questions we have looked at so far, apply the same principle. All right, apply the same principle to other questions. You see everything made easy. Now, if you look at this question, it says 180 gram of magnesium chloride was placed in 150 centimeter cube water to give a saturated solution at 150 degrees Celsius. If the solubility of the salt, so we're giving the solubility of the salt, it is what? 10.4, all right? at this temperature, what is the mass of salt undissolved? The mass of the salt undissolved. But if you remember, we were given 180 gram of magnesium chloride. All right, so 180 gram of magnesium chloride. So this is the I can call it the total mass of the salt. All right, total mass TM, total mass. All right, so that is what 180. Okay, so magnesium chloride, we need to get the molecular, the molecular mass, right, of magnesium chloride. We need to get the molecular mass of magnesium chloride. Please, before then, take note that the atomic mass of magnesium is 24, chlorine is 35.5, right? Please don't forget that. So, we're just going to add up. So, it will be 24 plus 2 times 35.5. So when you do this in your calculator, you're going to get 95, all right, gram per mole. So this is the molecular mass. Okay. Now, having gotten this, let's go into calculations. Now, we want to find the mass that is what undissolved, mass undissolved. So we're going to use our normal formula. Solubility is equal to mass times 1000 over molar mass times volume. So solubility is 10.4 equal to, we are looking for our mass, we call it X times 1000 all over molar mass, which is 95, times, remember our volume is 150, so 150 centimeter cube. All right, so that is the essence of this 1000 here. It's going to convert it to dm cube. So by the time you do this, you have 10.4 equal to 1000 times x is 1000x all over 95.95 times 150. So by the time we cross multiply, what do we have? We're going to have, by the time you just cross multiply and apply division, all right? So you just have x is equal to 10.4 times 95 times 150 all over 1000. All right, so therefore we're going to have x is equal to 148.2 gram. All right, so now to get the mass of salt undissolved, so it will be our total mass 180 minus 148.2. So by the time we do this, now this is our total mass minus the mass, all right, we just calculated here. So we'll now get what our final answer will be 31.8 gram. So this is the mass of the salt undissolved. All right, so thank you very much for watching this video. Please do it to like, share and subscribe to this channel, and make sure you also turn on your notification bell after subscribing, so that you'll be the first to get a new video. All right, whenever I drop the video, you'll be the first to get notified. So thank you very much for watching, and I'll see you in the next video.